In this chapter, the most important concept to understand is the mole flowchart. In the center of the mole flowchart is the word mole, and branching off of it, you have different things you can convert moles into. One of those is grams, and then to the right, I put molecules or formula units. And the difference between these mathematically are the same, but chemically they're different. You use the word molecules whenever it's covalently bonded together. So this would be like water or any other covalent molecule. Formula units are used, however, when we're talking about something that's ionic. So this could be like sodium chloride. Finally, there's also atoms. So in this simplified version of the mole flow chart that we're going to cover this year, you can convert between grams, moles, molecules, and atoms. You can start at one and then move to any of the others by following this chart. So it's reversible. Okay, so let's talk about grams to moles first. To convert between grams and moles, the idea behind this is if you actually have a sample in the lab, let's say it's 5 grams of carbon, and you want to know how many moles of carbon that is, you would use this conversion to figure it out. The first thing you need to do is figure out the molecular mass of the unit of whatever it is you're dealing with. And in this example, it would be the molecular mass of carbon. That molecular mass would equal 1 mole of carbon. So your conversion factor between these two can vary depending on what you're dealing with because the molecular mass can vary. Now let's say you didn't want to just figure out how many moles of carbon it is. You wanted to figure out how many atoms of carbon it is. Because it's just one element, you use this shortcut that we have here. So if it's ever one element, you can go directly from moles to atoms. And the way you do that is 1 mole equals Avogadro's number, 6.02 times 10 to the 23rd atoms. So here we can go directly from moles to atoms since we're dealing with carbon in our example. Now, let's say we were dealing with something else. And we started with grams again. So we're over at grams. Maybe it's carbon dioxide. We have 5 grams of carbon dioxide. And we want to figure out how many atoms of, let's say, carbon are in there. You would start with the grams, and then you would go use the molecular mass to go from grams to moles. So you go across here. And now because it's not an element, you have to go across again. So you're going to go from moles to molecules. The way to convert between those two would be 1 mole equals 6.02 times 10 to the 23rd molecules. Or if we were talking about something else, it would be 6.02 times 10 to the 23rd formula units. It just depends if it's covalent or ionic. Again, the numbers, the math won't make a difference. So now that we know how many molecules we have, we can figure out atoms by going from molecules to atoms. All right, to go from molecules to atoms, you would say 1 molecule equals however many atoms is in that molecule. And to go backwards, you would do pretty much the same thing. So you would just use these conversion factors to go back and forth, and the conversion factors are going to be circled in green. So that's kind of the mole flow chart. Now, I'm going to do it again with examples, and we'll do those below. So the first example is the one we were talking about before with just carbon. So let's say we have 5 grams of carbon. To go from grams of carbon, we're looking for atoms of carbon. So the first thing that we have to do is we know we're starting here in grams, and we want to get all the way to atoms. So if we take a look at the flow chart, we're going to have to go from grams to moles, and then because it's one element, we can take the shortcut and go to atoms. So as you can see here, the first word that's written is grams. That's what's here. The next thing that's written is moles, which is going to go up here. And then the next thing that we have is atoms. So by using the mole flowchart, you can actually figure out what's going to go on the top for your problem. Now, to figure out what goes on the bottom, it's whatever you have here. So it's on the top from the one before, gets put on the bottom of the next one. So moles is going to be put down here. Grams is going to be put down there. So it's going to go grams down here because there's grams up here. Grams of carbon. Okay, now this is where we have to look at the mole flow chart to figure out, well, what numbers do I put in here? So for example, we need to figure out what number goes here and what number goes here. And if you look at the conversion factor between grams and moles, it tells you. It says the molecular mass equals 1 mole. And one thing in this chapter is most of the time when you see the word mole, it's going to be a 1. All right. Now, to figure out the molecular mass of carbon, you have to look at the periodic table. So on the periodic table, you'll see a C. The top number should be a 6, not a 12. And then at the bottom, you'll see 12.011, whatever it happens to be. That's the molecular mass of carbon. So for this one, we're just going to round it, and we round all of our elements to just 2 decimal places. So up here, we would write 12.01 grams. So now we know what goes on the bottom, we have what goes on the top, and now we can move on. So as we said before, whatever's up here gets put on the bottom. So moles is going to go down here. And like we said before, because the chapter, whenever we're dealing with moles, it's going to be a 1. Now, if you want to double check that, which you should, you take a look at the conversion factor, because right now we're talking about going from moles to atoms. So if you take a look at this one, we have, all right, 1 mole. So it's still 1 mole of carbon. So let's get rid of that S. And that equals 6.02 times 10 to the 23rd atoms. So now we have this number on the top, and we have atoms, which is what we're looking for. So that's why we're going to stop here, because it's going to be atoms of carbon. Okay, now we need to cancel some stuff out. So for example, there's grams up at the top here, so that's going to get canceled out with grams on the bottom. There's moles over here. Moles are going to get canceled out. So the units that we're left with are atoms, which is where we get this from. And then to solve this mathematically, what you would do is you multiply everything that's on the top together. So that would be like 5.00 times 1 times 6.02 times 10 to the 23rd. So you multiply those numbers together, and then you divide by what's on the bottom, which is 1 times 12.01 times 1. So once you solve for this, that will tell you how many atoms of carbon you have. And there's 3 sig figs, so it's going to be 2.51 times 10 to the 23rd atoms of carbon. And that's how we start at grams, we go to moles, we go to atoms, and we get our answer. Okay, now let's do this again with something where we actually have to go a little bit further, where there's molecules involved. So let me erase. Okay, so now we're going to do 5 grams of carbon dioxide. So this is a covalent molecule. We know that because they're both nonmetals, so we're going to have to go to molecules for this. All right, now if we use the flow chart, we can actually figure out what's going to be on the top for everything. So in this case, I'm going to do like a highlighter. So I'm going to start with grams. So we're going to start with grams because we have grams here. And then we're going to have to go to moles. And then we can't use the shortcut now because we're not one element, we're a molecule. So we have to go across, and it's called molecules because they're both nonmetals. Once we get to molecules, then we can go down to atoms. So everything that's going to be on the top is where we just kind of traveled across. So the first one is obviously grams, we got that. Then the next one's mole. The next one is going to be molecule. And then finally the last one is atom. And it'll be atom since there'll be more than one. And now to figure out what goes on the bottom, we just do what we did before. So for example, there's grams here, which means grams is going to be on the bottom. Grams of what? CO2. Now the units aren't going to change throughout this. So we'll have moles of CO2, all right? The next thing we'll have here is this mole, same thing, it's going to get put on the bottom so that it cancels out. And it's molecules of CO2. And then molecule is going to get on the bottom as well. Now that we know what goes on the top and the bottom, we use the mole flow chart to figure out the numbers for everything. So let's go back and do that. Now, if you remember going from grams to moles, the conversion is using the molecular mass because that equals 1 mole. So again, mole is going to be 1, but now we need to figure out the molecular mass of this. So it's going to be 12.01 because that's what carbon is. And if you look at oxygen on the periodic table, it is 15.999, But if we round it to 2 decimal places, it's going to be 16. And because there's a 2 there, it's going to be 32. So now the molecular mass is going to be these things added together, which is going to give us 44.01. All right, so that's molecular mass. The next thing we're going to do is this one. So we're going to go from molecules to moles, which is all the way through here. So again, 1 mole, it's 1. Molecules is going to be Avogadro's number. Okay, so those are the numbers for that one. And then we have molecules and atoms. So it says 1 molecule equals the number of atoms, right? Well, there's 1 carbon and there's 2 oxygens. So there's 3 atoms in this. So that's where we get the 3 from. Mathematically, we're going to multiply everything on the top. So it's 5.00 times 1 times 6.02 times 10 to the 23rd times 3. And then on the bottom, it is divided by 1 times 44.01 times 1 times 1. So there's not much going on the bottom. So we multiply across, and then we divide by that 44.1, and that'll give us our answer. And that should be 2.05 times 10 to the 23rd. And we're talking about atoms. Now, we didn't pick what kind of atoms. We just said there's 3 atoms in there. So you wouldn't write like atoms of carbon or atoms of oxygen. It's just atoms. And that would give us our answer for that one. Now, let's talk about canceling out units. We have grams up here, which are going to cancel out with the grams at the bottom. Moles and moles are going to cancel out. Molecules and molecules are going to cancel out. The only thing that's left are atoms on the top here. And that's how we ended up with this right here. Okay, I hope that helps.